Here we go. You guys ready? So what we worked on 2 days ago on Monday, we focused primarily on these two. Well, really, we did the radian one. I don't remember covering the degree one, but it's the same thing. Notice there's a plus minus in the front. We're going to talk about where that comes from. When you do arc sine, okay, so anytime you do arc cosine and arc sine, there's always two solutions. Why? Because in the unit circle, when you do one revolution, there are two solutions. Chop, I don't know what you're talking about. So if I tell you between 0 and 2 pi, where is cosine a half? I hope that you tell me in quadrant 1 and in quadrant 4. In quadrant 1, cosine is a half at pi over 3. And in quadrant 4, 5 pi over 3. So cosine of pi over 3 is a half, cosine of 5 pi over 3 is a half. Does that make sense? See how there's two of them? Every time you do a revolution, there's two answers. So that's why there's a plus minus right there. The plus one gives you the one in quadrant 1, and the minus one gives you the one in quadrant 4. And then, so, chop, but I thought you can't have negative. Well, you can, but if you add 2 pi, that will give you that positive one, right? So negative pi over 3 plus 2 pi will give you that 5 pi over 3. Does that make sense, guys? Okay, what about sine? Why does sine have, sine has two solutions as well. If I tell you where is sine a half, I hope that you tell me at pi over 6. Sine of pi over 6 a half. Where else is it a half? In quadrant 2, sine of 5 pi over 6 is also a half. Is that making sense? Okay. No matter how hard you try on the calculator is only going to give you one answer. It's not going to give you the second one. So I want you guys to see. Look, check it out. Here's my calculator. I have it in radian mode really quick. I guess I already talked about cosine being a half. So check it out. Let me go ahead and type in pi over 3 first so you guys can see what that is in decimal. So here's pi over 3. Here's what that answer is. 1.047197. So where is cosine x equal to a half? Well, I know that one answer is pi over 3, this one. And I know that the other answer is 5 pi over 3. But no matter how hard you try, so here's 5 pi over 3. No matter how hard you try, the calculator will never give you 5 pi over 3. Look, chop, I don't know what you're talking about. Our cosine, here's 0.5. And look, I'm going to push enter. Look at that, 1.04. But how come it doesn't give me the 5.23? I bet you this is our cosine. I bet you if I take this one, let me go ahead and put a negative in the front. If I take this one right here, the pi over 3, and I make it a negative, and I add a revolution, if I add 2 pi to it, I bet you I'll get that 5 pi over 3. Oh, look at that, 5.2359, which is 5 pi over 3. Do you guys see what's going on? No? Okay, here's what I'm trying to say. Cosine of pi over 3 is a half. See? Cosine of 5 pi over 3 is also a half. But no matter how hard I try, the calculator will never give me the 5 pi over 3 answer. Look, if I do inverse cosine of 0.5, it'll never, I can type this 1,000 times and it will never give me the 5 pi over 3, even though 5 pi over 3 is an answer. So what am I saying? Remember that plus minus? That's how you get the second answer. See that negative right there in front of that? See that? Look, you see how the only answer I get, why can't I scroll up? Oh, I guess I got to push this button here. The only answer that the calculator will give me is pi over 3 over and over again. Pi over 3 is 1.04. But if I put a negative in the front and I add 2 pi, that will get me the 5 pi over 3. So that's why I'm saying our cosine is plus minus. When you do inverse sine, you don't put plus minus. You look. I'm trying to derive these questions. See, when you do the inverse sine doesn't have a plus minus. Inverse sine just has arc sine of it and then pi minus arc sine. I'm going to show where that comes from. We just proved this one, see? So I guess maybe you guys are visual learners. So let's draw a little circle. Try not to draw it too big. Draw it like 1/4 of this right here. So let's derive these answers. So here's my unit circle. And I care more about the radians and the coordinates. And I guess we'll just coordinate square root of 3 over 2, comma 1/2. Square root of 2 over 2, comma square root of 2 over 2. 1/2, comma square root of 3 over 2. And then 0, 1. This one's 1, 0. This one is 30 degrees and pi over 6. 45 degrees, pi over 4. 60 degrees, pi over 3. Okay. And have I told you cosine x equals a half, because that's what we've been doing lately? How do I get x by itself? By doing the inverse, right? X equals arc cosine of a half And if it's something like that, well, we know that the answer to that is one answer is pi over 3, and the other answer is, if I'm only looking between 0 and 2 pi, the other answer is 5 pi over 3, right? But the calculator, no matter how many times I push this on the calculator will only spit out pi over 3. So recognize that I can get the 5 pi over 3 if I go negative pi over 3 plus 2 pi. 2 pi is the same thing if I get common denominator times 3 over 3, 6 over 3. Negative 1 plus 6, oh look, that is 5 pi over 3. That is that. Do you see that? But no matter how many times I push this in the calculator will never give me the 5 pi over 3. So that's why we say, oh, when you do arc cosine, do the plus minus. Plus minus only happens for the arc cosine. And then look, you'll get your answer. So if I say x equals that, x equals plus minus pi over 3 plus, that's a 3, it just came out ugly. Pi over 3 plus 2 pi n. I can go x1 equals pi over 3 plus 2 pi n, and that will give me all the answers on this branch. And then to get the other answers on the other branch, negative pi over 3 plus 2 pi n. That will give me all the answers on this branch, where this coordinate is also square root of 3 over 2. Negative 1 half. Does that make sense? Okay. Bless you. Oh, sorry, that's not a, that's a cough. You okay, miss? Okay. All right, arc sine. If I do arc sine, so if I go arc sine of a half, you and I know that arc sine of a half happens in quadrant 1 and quadrant 2. That answer, let's see, so if I go equals x, and I go, okay, well, x equals, I'm reading the same thing. So arc sine of half, where did that happen? Well, one answer is pi over 6. Thank you, miss. Plus 2 pi n. Here you go. You need one of these, unless there's already one there. Just in case. One answer is pi over 6. Where's the other answer at? Well, this one. Yeah, 5 pi over 6. But notice, here's what I want you to notice, guys. No matter how many times, first, I guess, let me show you what pi over 6 is. Second pi in decimal. Pi over 6 is 0.5235. No matter how many times I push arc sine of 0.5, it was only going to give me this answer. But you and I know that sine of 5 pi over 6 is also an answer. Look, sine 5 pi over 6. And look, it's also a half. It's also a half. But no matter how many times I push arc sine of 0.5, it's always going to give me this answer. So how do I get the second branch? How do I get this second angle? Well, you can get that second angle by doing pi minus arc sine of a half. See? Pi is pi. And then arc sine of a half, the calculator answer is always going to be pi over 6. See? And if I do that, look, put a 6 over 6 for that pi there. What's 6 minus 1? Not everyone's, yeah, 5. Not everyone at the same time. And look, you get your 5 pi over 6. Do you guys understand what I'm trying to portray here? No matter how often, no matter how much I put arc sine a half, the calculator will always just give me pi over 6. You can go to Wolfram Alpha. Do you guys know about Wolfram Alpha? It's kind of like an AI, but for math. It's a CAS, computer algebra system. Wolfram Alpha, you get a free account once you're university. Well, okay, don't quote me because maybe not all university, but if you go to an engineering university, you're going to get a free Wolfram Alpha account and you'll have access to Desmos and MATLAB, all the fancy software. But if I go to Wolfram Alpha, there's Wolfram Alpha, and I go, wow, check it out. So look what Wolfram Alpha can do a lot, by the way. And I go, let's see, what am I doing? Arc sine. So if I go arc sine and I put 0.5, oh, okay, it's give me a fraction, 1/2. And look, it does it for you. Arc sine, and look what it says, exact result. Can you guys see that? No matter how many times I push arc sine on this, this will not give me 5 pi over 6. It's just going to give me pi over 6, pi over 6, pi over 6 all the time. So how do I get the 5 pi over 6? Pi minus arc sine. Look, if I put a pi in the front, if I go pi minus arc sine a half, now I'm going to get 5 pi over 6. Look at that. Am I making sense, guys? Okay, that's where this formula came from. Do you need to know the formula? No, because you can do it with logic. But I am going to expect you guys to know that because I'm going to give you some coordinates that are not perfect. Uh, of course, for if you're in honors, well, no one here is in honors. It is the AP class. They can just do it with graphing. You don't have to do it algebraically. Just graph it and see where they intersect. Uh, the left hand side and the right hand side. But do you guys know what I'm trying to get to? Okay, you'll see what I mean in a little bit. And what about the arctan? Why does arctan only have one answer? Okay, guys, arctan only has one answer. Oh, by the way, Wolfram Alpha, for those of you that are barely experiencing Wolfram Alpha for the first time, I'm not telling you, don't use it to cheat. I'm telling you, like, use it to help you out. Like, look, if you want to type the word factor in the front, and let's say I don't know how to factor x squared minus 4, I hope everyone knows that's the difference of squares. But if you didn't factor, you put the word factor in the front, and you go x squared minus 4, you close it, and you push enter, and then look, it does it for you. It shows you how x squared minus 4 looks like, and it shows you the zeros. Isn't that cool? You guys don't like it? It does a whole bunch of stuff. You can push the word solve, and then let's keep it simple. X squared minus 4. X squared minus 4 equals 0, and then close it, and then push enter. And then look, x equals plus minus 2. What's the name of this website? Wolfram Alpha. There's also an app. Once you're a university student, you can get like the Pro Edition, upgrade to Pro. Let's see how much it is for students. For students, pricing. So let's see, it's free for the basic, $5 a month. It's billed annually, so they bill you, so they trick you. It's not really $5 a month then. They bill you right off the bat, $60. And if Pro Premium, complete access to all features, priority customer support. No, you don't need the customer support. So there it is. It's a good investment if you have $60, but if you don't, then don't worry about it. Once you become a university student, you'll get it for free if you're at a STEM school. Just say, hey, I heard that you guys have free Wolfram Alpha subscriptions. And like, oh yeah, here you go. And they'll give you a code, and I'm sure you can, whatever. If you're a university student, you get like a whole bunch of discounts all the time for everything. You get like Amazon, I think, free or discounted. You get Spotify or, for a discount. Anyways, I'll stop. So why does arctan just have one formula? I'm going to see if I can do it easy, guys. So let's focus on, so let's say I told you I want to know where tan x equals 1. So I'm going to do inverse, and I'm going to say x equals arctan of 1. Well, we know that arctan of 1, well, look at this. Right here at 45 degrees, I have the x coordinate and I have the y coordinate. This is why the unit circle doesn't go away. And I can see that y divided by x, I'm going to get 1. Do you guys see that? I also know that right here at this location, that's negative square root of 2 over 2, negative square root of 2 over 2. I also know that y divided by x is also 1. Do you guys see that? Notice, make an observation, from here to here. Isn't that just plus pi? That's a linear line, no? So that's why you can just go arctan 1 plus pi, and those will always give you the answers. So at pi over 4, at 5 pi over 4, that's just pi over 4 plus pi. So if I go tan of pi, obviously that's tan of pi over 4. Tan of pi over 4. You get 1. Tan of 5 pi over 4. You get another 1. See? And 5 pi over 4 is just pi over 4 plus pi. You guys know that, right? I hope you guys can see it. 5 pi over 4 is this number. And look, if I type in pi over 4, and I'm not, I know you guys are not dumb. I'm not trying to, chop. I know that pi over 4 plus pi is 5 pi over 4, 4 pi over 4, right? It's pi, but plus pi, it's the same digit. See? Are we cool? Okay. So there it is, guys. I hope that, and I don't know, it's having math last period is so hard to concentrate, but these formulas come from somewhere. I hope you can see where they come from. You don't necessarily need to memorize them. You can just derive them from logic. You'll use them whenever it comes to solving problems like this that are not perfect. So notice that it says solve the equation 10 sine x minus 0.2 equals negative 3 algebraically. So that means doing it this way. That means doing it like this. And it says in the domain 0 to 4 pi, verify the solutions graphically. Okay. My first deal, what am I going to do? I'm going to write the expression out. 10 sine x minus 2, or 0.2, equals negative 3. Are we okay so far, guys? All right, my first move. I need to get rid of that 10. What am I going to do? Divide. So I'm going to write sine x minus 0.2 equals negative 3/10. Are we okay so far, guys? Okay. Next move, I need to get rid of that sign. What am I going to do? Inverse or arc. X minus 0.2 equals inverse sine of negative 3/10. And if I do a revolution, I'm back in that same location. Does that make sense? Are we still okay? Okay, put an asterisk on this one because we're going to go back to that in a little bit. All right, I'm trying to get x by itself. Or what I got to do, just move the what? The 0.2. Just put it in front of that. X equals 0.2 plus arc sine of negative 3/10 plus 2 pi n. You're going to type in your calculator this right here that I'm putting in blue. Do you guys see that? All right, so I'm going to write x1 equals, and I'm going to take my calculator, make sure you're in radian mode. Hopefully you reset it. And here we go. I'm just going to go 0.2 plus arc sine, and I already forgot, what was it? 3 over 10. Negative 3 divided by 10. If you want to write negative 0.3, that's fine. It's not a big deal. It's the same thing. I'm going to push enter. And there it is. Negative 0.104692654. I'm probably not going to be able to remember all that. Negative 0. Yeah, I already forgot. See? 1, 104, 69, 2654. Like that. Plus 2 pi n. Are we still okay? All right, I'm going to change my color, my ink. If you have colored pencils, if you have different types of colors, here's a good place to change the color. I'm going to write my next expression. That's okay. So I want to make sure that we're clear why we're doing that. This will only give me half of my solutions. Does that make sense to everyone? Remember, when you do between 0 and 2 pi, arc sine is equal to some value twice. Arc sine is equal to half twice in quadrant 1 and quadrant 2. Arc sine is going to be equal to negative 0.3 twice in quadrant 3 and quadrant 4. Or negative 3/10. That's what I meant to say. Because sine is between negative 1 and 1. Not, you know what I mean? Okay, so here we go. In blue, I'm going to start right here where the asterisk is at. I'm going to go x minus 0.2 equals, and I'm going to write pi minus arc sine of negative 3/10 plus 2 pi n. Child, what are you doing? I'm just doing this. I'm just doing this right here like that to get my other solutions. Does that make sense to you guys? Okay, so there it is. Are we still okay? All right, I'm just going to move the pi. The negative 0.2. X equals 0.2 plus pi minus arc sine of negative 3/10 plus 2 pi n. This right here is what I'm going to type in the calculator. So I take my calculator. I'm going to go 0.2 plus pi. Chop, can't I just adjust it with pi? Well, you got to be very careful if you're going to scroll up and just go plus pi or whatnot. But because I've seen a lot of mistakes. So just do it again. Plus 2 plus pi minus arc sine of negative 3/10. Yeah, you can see that. Yeah, I would just do it again. 0.2 plus pi minus arc sine of negative 3/10. 3.646285308. I'm not going to be able to memorize that. You guys will help me out. I'm going to put a 2 on the bottom of this. X subscript 2 equals. Help me out, Delgadillo. 3.646285308. That's all the digits. Plus 2 pi n. How do we feel? Okay. Notice what it said here. In the domain 0 to 4 pi. In case you don't know, I mean, you don't need it because we're going to be adding 2 pi anyways, but if you want to turn 4 pi into a decimal, there's my 4 pi, 12.56637. 12.56637. So I want all the answers for x between 0 and 12.56637. You guys ready? I'm going to go to neutral color, so black. X equals, is this my first answer, the negative 0.104? Be careful. Well, it's not my first answer within the domain. No. So this is going to have to be my first one. Does that make sense? So I'm going to write 3.6463. At least at least 3 digits. If you can give me more, even better. Then my next one, this one came from x2. My next one's going to come from x1, adding what to that negative number? Adding what? Yeah, so scroll up. Look, I'm just going to scroll up. You don't have to type it in from the beginning. Push enter. I'm going to go plus 2 pi. Enter. There it is, 6.17849. 6.17849. That one came from x1. Are we still okay? ¿Estamos bien? Okay. Sorry, didn't mean to freak you guys out. How do I get the next one, guys? Add 2 pi to which one? To the first one, 3.64. Yeah, don't be scared. So I'm gonna, I don't know why I just thought of a song, but it's not even. It's like such a random song from a random movie. I don't think you guys will ever guess it. 3.64 plus 2 pi. I'll sing in a little bit if I can remember all of it. 9.92947. 9.92847. I think it's from a movie. Let's see. It goes, it's all right, it's okay. You never loved me anyway. Does that sound familiar to you guys? Yeah, it's such a random movie. I don't even know. Maybe I'll Google it tonight to see what movie it was. It's all right, it's okay. I never. No, okay, that would be so mean. You never. Yeah, I don't remember. It's okay. Let's stick to math. X2, X1, X2. Sorry, guys. The next one's going to come from X1. Take the 6.1784 and add 2 pi. 6.1784, and I'm going to add 2 pi. Plus 2 pi. I don't see any mistakes. I think we're good. 12.4616. 12.4616. So I guess 17 if you're rounding. And that's it. If I take the 9.92 and add 2 pi, it's going to be outside that domain. Cool or not cool? And I know it says here, verify the solutions graphically. And you're like, well, Chop, why did I have to do all this? Why couldn't I just do it from the beginning graphically? Well, we want to make sure that you're getting a quality education. So type this in Y1. Y1, 10, sine x minus 0.2, x minus 0.2. And then in Y2, I'm going to type what? Negative 3, negative 3, negative 3. Okay, don't push graph yet. So, Chop, how do I fix my window? Because that's the biggest issue, right? And don't worry, I'm going to slow down. I got your reviews. You guys want me to slow down when it comes to the calculator usage. I'm going to slow down. Okay, ready? Push the window button. So, x min, x max. Well, I'm going to get that from here. See how it says I want to look between 0 and 4 pi? So, that's what I'm going to do. I'm going to make my x min 0, so put 0. I'm going to make my x max 4 pi, so push 4 pi. The pi is where the caret's at. Chop, what about the y min, y max? Okay, well, let's see. Let's look at the sinusoid. The sinusoid is 10 sine x minus 0.2. My min, well, the midline is 0, so the amplitude here goes up 10 from the x-axis and down 10 from the x-axis. So that means my minimum is negative 10, and my maximum has to be, so that's what I'm going to make my min and my max, negative 10 and 10. Do you guys see how I did it? There it is. Mine's already a negative 10 and 10. I'm going to push graph, and there's my graph. Estamos bien. All right. I'm going to find these intersections. 1, 2, 3, 4. I'm going to find the first two, and you guys find the last two. And let's see if they match. Second, calculate number 5. And I'm going to enter, and then guess. I'm going to scroll to the first one. I'm going to push enter. 3.6462. Did we get that? I'll do it again. Second, calculate number 5. Enter, and if I want to get the second one, make sure that it says the word intersection. Enter. Bless you squared. Oh, that was a cost, sorry. 6.17849. Did you get that? There it is. And we got that answer also over here. 6.17, look, 6.17849. So how do we get the third one? I'm going to do the same thing. Second, calculate. Make sure you practice, guys, so we got it down. Number 5, intersect, enter. And I'm going to scroll to the third. Enter. Slide to the right. Slide to the left. Crisscrosses. Okay, I'll stop. I wish I had a button to push, like pyrotechnics. And Well, I don't think you can have pyrotechnics inside a constrained small room like this. Plus, I don't know if I have the budget to buy all those stuff, you know? Maybe I can buy some black cats and then just. Oh. Sorry, YouTube. I did not bring any type of fireworks into this classroom. So, how do we feel? We feel okay? All right. All right, real quick before we continue, guys, I just wanted to tell you guys that some of you guys know how to do some of this, but when it comes to exam, I don't see you guys ever using these skills that you're learning. Chop, what are you talking about? So let's say you're taking an SAT or an ACT, and I don't know. I'm just gonna make something up, guys. I'm just gonna make something up. Let's say you have like x squared equals. Okay, let's make it more complicated. X squared minus 25. No, that's too simple. X squared minus 17 equals x plus 4. I don't know. I'm just making something up. Uh, and that's fine. If you have a calculator, that's fine. You can like get this in standard form and then see, use a quadratic formula or factor it out if possible. But guys, use your tools. If you think you're faster, especially if you have Desmos, if you think you can put that in Y1 and put that in Y2, and then the only answers are going to be wherever they what? Intersect. Or if you can go to Desmos really quick, Y1, and type this into one of them and type this into the other bracket, or whatever. See where they intersect. But I don't know, like you guys take a test and it's like you guys don't know about all these skills that you've been using in math class. You know what I mean, guys? So use your skills, guys. I mean, obviously sometimes it's faster to factor, but use your logic of what you think is faster for you guys. All right, let's go to the next one. I'm not sure why I put in degrees. Maybe you guys think that degrees are easier. So I guess let's go to degree mode. So mode, degree. On the exam, I don't like going back and forth between degrees and radians. So I'll just put 1 and that'll be it. So there it is. My calculator is in degree mode. And it says solve for the first 3 positive values. It doesn't tell me how to solve it. I guess I could solve it with like just typing this into the graphing calculator. But let's practice algebraically. So I have 4 tan x equals -5. What's your first move? Divide by 4. So I'm going to write tan x equals -5/4. Are we still okay? All right, what's my next move? Inverse. X equals arctan of -5/4. And because we're in degree mode, I'm going to write plus. And all I'm doing is stealing it from here. Look what it says if you're in degrees. It says arctan of whatever you had plus what? 180n. I'm going to show you a hack with the calculator. Now, why I like these calculators so much. So I take my calculator, and you only have to run this code one time, and then the rest of the time you can just push enter. So check it out. I'm going to go arctan of -5 with a -5/4 or 4/5. -5/4, and I'm going to push enter. Is that an answer of mine? Let's see what it said here. Yeah, I think I heard you say it correctly. It says, what did it say there? First 3 positive. Is that an answer then? No, that's not an answer. So what do I do to that answer? I'm going to push what? Plus. No, we're not in radians. We're in degrees. So instead of, and not 2 pi, but pi. But we're in degrees. So I'm going to put plus what? 180. So I put plus 180. Do it like this, where it says ANS. ANS stands for answer. And look, when you push enter, you get an answer. So obviously, that's not a surprise. You're like, okay, it's supposed to give you an answer. 128.6598. So let me put that down. So one of my answers is 128.6598 degrees. Close. Make sure to put a degree symbol. All right. You do not have to do anything anymore. You don't have to lift. Well, I guess you have to lift a finger, but you just got to push one button. And look, you just push enter again, and it's going to execute the last line. So you're going to push enter, and look what it does. It gives you the next answer. Isn't that cool? 308.6598. 308.6598 degrees. Push enter again. Bam. 488.6598. And there it is. Those are the first 3. 488.6598 degrees. Now, I know we haven't talked about tan, so let's practice with our graphing calculators how to type this in. We will talk about tan and arcsecant or secant and cosecant next Friday. Hopefully, we have a regular Friday next Friday, right? We'll practice graphing that, but we're not there yet. But let's practice. So on y1, I'm going to type in 410x. So 410x. And on y2, I'm going to type in, I already forgot, -5. And then click on window. I'm going from 0 all the way. Well, I already know the answers, so it went all the way to 48. So I'm going to put all the way to 500. And because I don't want the x scale to be bumbled up or jumbled up, all those little hash marks, let's make the x scale by 50. And then y min, well, this actually 10 goes up forever and down forever. So -10 is perfectly fine. -10, between -10 and 10 is perfectly fine because we're looking where it's -5. -5 is somewhere in there. Does that make sense? So I'm just going to go ahead and push graph. Don't worry, we'll have more experience with graphing tan and secant and cosecant. And there it is, guys. I bet you those 3 answers right there are the answers that we got. Isn't that cool? Second, calculate number 5, intersect, enter, enter, and then scroll to whichever one you want. I want this first one. I'm going to push enter, and I bet you it's going to be that answer that we got. Did we get 128.6598? Yeah. Second, calculate number 5, enter, enter. I'm going to go all the way to the last one. Way over here. I'll push enter. Bam. 48.6598. Did we get that? Yeah, good job. We're done. We're done with that. Cool or not cool? All right. Let's see how we do with this. Don't worry. We'll be fine. Do you guys have issues with factoring from your algebra days? Or do you guys feel like you're pretty good? You're not good? You don't feel like you're good? Okay. So it says in degrees, solve algebraically, all this stuff. Okay, let's see if we can first know how to factor. Let's do what I put. Remember or from out. Okay, I'm gonna put the word similar. This is similar to x squared minus x minus 2 equals 0. It's similar to that. Real quick, you see how this says sine squared? You see how the squared's right after the n? So sine with a square on the n, x means sine x, close it squared. I know authors are really bad about putting parentheses on their arguments. They should be putting them like that, but they, for whatever. It also does the same thing. So that's what it means, guys. If you write sine x squared, people might confuse that as saying sine of x squared. Do you guys see that? So you're not squaring sine if you put the square right after the x. There's always a battle. There's always a battle on Facebook of teachers fighting teachers about that really means this. And I don't fight. I'll just say, guys, type that into your calculator and see what it does. So if you type it like this, it means that. So if you want to square sine, you gotta put it right after the n. So we know that sine is being squared. So that on the left means this on the right. Are we okay? Okay. So do you see how this is similar to this? Now, when you were in Algebra 1, maybe Algebra 2, Ms. Gonzalez probably taught you, of course, you could always do this with a calculator, type it in the calculator, see where it crosses the x-axis. Yes, you can probably use the quadratic formula as well. But something like this, you probably want to just factor, because that's probably the easiest route. Look, how do you factor this? Well, 2 numbers that multiply to give you -2 that add up to a -1. Not everyone at the same time. Yeah. -2 times +1. -2 times +1 is -2. And -2 plus 1 is -1. Do you guys see that? And that equals 0, so I'll put equals 0. That is that. And why do mathematicians and everyone, why is everyone always equaling stuff to 0? Because it's easy to analyze. It's easy to evaluate. The only way you're going to get a 0 here is if you multiply by 0. Do you guys agree? So how do I get a 0? Well, if x is 2, 2 minus 2 is 0. 0 times anything is 0. See? How else can I get a 0? Well, if x is -1, -1 plus 1 is 0. 0 times anything is 0. And that's a demerit. Okay. Do you guys see how we're doing it? Okay, so we're not robots, right? We understand why stuff happens. All right, so it's the same thing with this, guys. So if you have sine squared, let me write it like this. Sine squared x minus sine x, and I guess I'll put a parenthesis like that, minus 2 equals 0. Remember, this is similar. This is similar to the one on the left. See, it's similar. Do you guys see that? So when I factor this, so factor, or factoring. When I factor this, or when we do factoring, here's what I get. I get sine x minus 2 sine x plus 1 equals 0. Are we still okay? And just like before, the only way this will be 0 is if sine x is 2 or if sine x is negative 1. Negative 1 plus 1 is 0. 0 times anything is 0. Are we okay? Okay. Well, sine x will never be 2 because sine x is a number between negative 1 and 1. The biggest it'll ever be is 1, and the smallest it'll ever be is negative 1, if you consider more or less small. Does that make sense, guys? Okay. So that means this one will happen. So that one that one's a check mark. So where does that happen? You don't have to do any fancy formulas. We're in degree mode. What degree is this one down here? Okay, I'm gonna write 270 degrees. And then I scroll up and then I look at this and it says x, which is my angle, is somewhere between negative 90 up to 270, but not including 270 because of that parenthesis. So is 270 an answer? No. What's my answer? What else could it be besides 270? Yeah, say it. No, not 260. It needs to be this angle. What's another angle besides 270? If I go like this, that's 270. But I don't have to go counterclockwise. I could have also gone what? Look what it says right here. So if I go like this, what angle is that? Yeah, say it loud and proud. What is it? YouTube, I swear they're answering. It sounds like they're not answering, but they're answering. It's negative 90, guys. Negative 90 degrees and 270 degrees are terminal angles. They're the same. Does that make sense? I mean, I know they're not the same angle, but it creates this same segment there. They share that same. Cool or not cool? So there it is. This is my answer. Do you see how we did it? Cool? Okay. All right. Go to the next one. I put in here, let's say you're in a job interview and you want, okay, anyways, it doesn't matter. So you have something like this. This is not factorable. How do you know it's not factorable? Well, you can't put them in pairs, binomial pairs, and there's nothing times something that will get you that. Like, Chop, I'm gonna figure it out. Like, no, you can't. Like, 4 times 3, that's 12x squared or 12 sine x squared. There's not a product that gives you 12 that adds up to a negative 2, right? Like 6 times 2, that doesn't add up to 2, or So we'll talk about the AC method later on. So what other method can I do? So this is similar to 4x squared minus 2x minus 3 equals 0. How would you solve that one when you had Gonzalez? Do you guys remember? Starts with the letter Q. ax squared plus bx plus c equals 0. Yeah, the quadratic formula, guys. X equals negative b plus minus square root b squared minus 4ac all over 2a. If I'm being honest, I think if I were to get this question, I would just do it with a calculator. Do you guys want to just see how to do it with a calculator? All right. So you see how it says equals 0? On your calculator, just go 4, open parentheses, sine x, close it, squared, minus 2 sine x minus 3. So that's what I'm going to do. So I'm going to take my calculator, and I'm going to go y equals, clear, and I'm going to go 4, open parenthesis, sine x, close it, and put a square on it. Does everyone know what we just did there? Okay, that's how you say sine squared. Minus, and you don't have to put a parenthesis on this one unless you really want to. There 2 sine x. So I'm just going to write 2 sine x, 2 sine x, close, and then minus 3. Minus 3. Now I just noticed my domain is in radians, not degrees. See, this is why I don't like toggling when it comes to exams between degrees and radians. My calculator right now is in degree mode, so I'm not ready. I need to have my calculator in radian mode. So click on mode and go to radian. Okay, now I'm ready. Go back to y equals. You guys ready? I'm going to click on window. You're only looking between 0 and 2 pi. So I'm going to go 0 and I'm going to go 2 pi. X scale by 1 is fine. Or if you want to put pi over 2, that's fine as well. Y min, well, let's see. You see this 4 in front of this sine squared? So I know it's not like a perfect, but I'm going to say like that's kind of like amplitude kind of. So I'm going to go up 4 and down 4. No, we're getting that's the next one of the demerit. So I'm going to go negative 4 and positive 4. I know it's not perfect, guys. YouTube, don't kill me. All right, here we go. You guys ready? Push graph. And there's my graph. There's the sinusoid. I'm going to find the answers. Remember, it equals 0, right? So I want to know where the y value is 0. Are you doing okay, Pearson? Okay. So here it is. I'm going to find it right here. Go to second calculate. Which one of those do you think is the one that I got to push? Which one? I heard someone say it, but say it loud and proud. Which one? Yeah, 0, number 2. That means where's the y value 0, guys? So push number 2. And look what it's going to say, left bound. All that means is, where do you want me to look? Where do you want me to look? Okay, that's to the left of this intersection, so I'm going to push enter. And then right bound. So I'm going to go to the right. I'm going to scroll. So there I am scrolling. I just got to pass it. Pass it like that. Boom. Guess, if I had several, then I would go to the one I want. I only have one, so you don't have to guess. You can just push enter. And then look, there it is. It needs to say the word 0, just like before when it said the word intersection. And it needs to say the word 0. What is that answer? 3.851, at least 3 digits after the decimal, at least. So I'm going to write sine x, or x equals 3.851. Did I write that correctly? 851, yep. All right, let me get the next one, guys. Make sure that you practice. Second calculate, number 2. And it says left bound. Let me scroll a little bit past that. I'm going to push enter here. Right bound, I'm going to go to the right of that. I'm going to push enter. Guess? Nope. 5.57377. 5.57377. Chop, I want to make sure that this question, that answer is absolutely correct. I'm going to show you how to do that if you wanted to. So check it out. Here's how you can show. Go to the home screen. Push X, and then push this button here so it stores everything in the register. Push this button next to the number 1. That stands for store. And I'm just going to go down the alphabet. And then look, it stores that number in there. Isn't that cool? Chav, what are you going to do with that? Like this. Look, I'm just going to call it. I'm going to go alpha trace, and I'm going to push Y1, which is where I have my formula. And I'm going to open a parenthesis, and I'm going to push A. And when I push enter, I better get 0. Oh, I got 0. This is the same thing as saying this. 4 times, open parenthesis, sine alpha A, close, squared, minus, I already forgot what the equation was, 2 sine A, minus 2 sine A, and then what was the last part? Minus 3. That's like what I did, but instead I already had it in Y1, so I just took Y1 of A. See, it works. Everything works, guys. Do you guys see how everything's coming together? Did you guys know about all these little features with the calculator? But now you do, though, right? Now you do. Use your calculator, guys. You can also do kind of the same thing with Desmos, but I don't think that feature is on Desmos. It may not, because the cut paste feature is not on Desmos. It is. It's right now on Desmos, but when you take your AP exam, I don't know if the cut paste feature is on Desmos. Desmos is awesome for highs, for max, mins, zeros, and intersections. But when you need intermediate steps, when you need to store something, I think the calculator is better. Okay. How do we feel? Do you feel okay? Okay, don't worry, we're almost done. We're almost done, Pearson. We're almost done. Go take a break. Go drink some water. All right. Here we go. 3 secant x equals negative 2. You guys ready? We're almost done, guys. We're almost done. So I want to get secant x by itself. The rest, you're not going to need any formulas. Divide by square root of 3 on both of them. So I'm going to write secant x equals negative 2 over square root of 3. If you feel like you can work with secant like this, then go ahead. Work on it like that, guys. What is secant the reciprocal of? Which one? So rewrite it. Write cosine x equals negative square root of 3 over 2. And then how do I get x by itself? By doing the inverse. X equals arc cosine or inverse cosine of negative square root of 3 over 2. I go to my unit circle. Negative square root of 3 over 2 happens in quadrant 2 and 3. Right here and right here. What's that coordinate? What's that coordinate? 5 pi over 6. What's the other one? There it is. Did we need any formulas? No, we didn't use any formulas. Look at that. We did it real quick. And that's okay. That's a demerit, miss. You yawned. Oh, because check it out. I'm only looking between 0 and 2 pi. If I was looking between 0 and 4 pi, I would have done plus 2 pi n. Only one. Yep. Does that make sense? Cool or not cool? Okay, don't worry. I'm going to show you this one. Look. Oh, Chop, I definitely need the formula for this. No, you don't. As long as it's equaling something. Okay, I'm going to go slow. Tell me, stop me if things get complicated real quick. You guys ready? All right, I'm trying to solve for x. I'm looking for values between 0 and pi over 3 that make this true. Are we okay so far? So I'm going to rewrite it. I'm just going to go cosine 6x equals 0. I'm going to put parentheses because the authors don't seem to be putting parentheses on their argument. How do I get rid of that cosine? Inverse. I'm going to write 6x equals arc cosine of 0. If you want, you can put plus minus, but I'm not referencing the formula. I know where that's at. I draw a unit circle real quick, and I'm like, cosine is 0 right there, because cosine is the x value, and right there. Are we okay? All right. Give me my first one. 6x1 equals, where's cosine 0? Pi over 2, and I'm going to write now, because it says pi over 3 here, I'm going to write, I don't know what's going on, so I'm just going to write plus 2 pi n and see what happens. Are we still okay? There's another general answer. I'm gonna change my color. So I'm gonna change my color. I'm gonna write 6x2 equals. Where's the other? Where is cosine 0? And what rating is cosine 0 besides pi over 2? 3 pi over 2, and I'm gonna write plus 2 pi n. Does everyone know what we just did? So this is why the unit circle never goes away, guys. All right. Are you guys ready? All right, here we go. I want to get x1 by itself. Without a hiccup, I couldn't tell. Demerit. How do I get x1 by itself, guys? Divide by 6. Whatever you do to 1, you do to the all of them. Divide by 6, divide by 6. Here's a hack. Saves you a second every time you do it. If you have a fraction, anytime you're dividing by 6, you just put a 6 right next to that. Child, why does that work? Because if I were to put divide by 6, keep, change, flip, the 6 is going to be next to the 2 anyways. Do you guys know what I mean? So here's what I have. x1 equals pi over 12 plus, this reduces to pi n over 3. Okay, now I'm going to go to the blue one. Okay, don't worry, I'm slowing down. I'm trying to get that x2 by itself, so I'm going to divide everything by. Divide by 6, divide by 6, divide by 6. Here's what I have. x2 equals, let's see, 3 pi over 12, or 3 goes into 6, 3 times pi over 6. Wait, did I do that right? 3 pi over 12, 3 pi over 4. Yeah, pi over 4. Plus pi n over 3. Okay. Are we okay so far? Okay. Does everyone know what we did? Okay. All right, let's get our solutions. X equals, I'm looking between 0 and pi over 3, so I'm going to look first at these two. Is pi over 12 between 0 and pi over 3? It is. Pi over 12, or 1/12 of pi, is smaller than 1/3 of pi. What about pi over 4, or 1/4 of pi? Is 1/4 of pi smaller than 1/3 of pi? Yeah, it is. 1/4 is like 0.25, and 1/3 is like 0.23. It's the same space, because you're good. So there it is, pi over 4. All right, notice that you have pi n over 3. That's because that's the period of this. If I had pi over 3, notice that will take me outside my domain, because I'm only looking between 0 and pi over 3. So these are my only two answers right there. Do you guys see that? All right, good job. Are we feeling okay, guys? Okay. Chav, I need a calculator. I don't know how to do these questions. These are the same questions that the math competition in Houston gave you guys when we did it last year. Who did the UH competition last year? Anyone here? These are the same questions they gave to the pre-cal kids. I just stole them from that math competition and put it in here. All right, look at this. Do you need a calculator for this? No, you don't. I'm solving for x. Don't worry, guys. We're almost done. We got 3 questions left, and then we're done. All right, here we go. Move the square root of 3 to the right. So 2 sine pi over 6x equals negative square root of 3. Are we okay? Say it again. What? Oh, we skipped one? Dang. Well, okay. We already started this one, guys. I'll go to that one in a little bit. Yeah, I don't know. No wonder you guys were looking at me all weird. How do I get rid of that 2 in the front? I divide. So sine pi over 6x equals negative square root of 3 over 2. What am I going to do next? Yeah, say it loud and proud. Inverse sine pi over 6x equals inverse sine of negative square root of 3 over 2. Do not put plus minus. That's for cosine. Plus 2 pi n. I draw a little unit circle. Let me draw it better. And I'm like, oh, that's a negative square root of 3 over 2. That happens in quadrant 3. Oh, not there. This one down here. And quadrant 4. That coordinate is negative half, comma, negative square root of 3 over 2. This coordinate is 1/2, comma, negative square root of 3 over 2. I'm going to go pi over 6x1. I'm going to put the subscript there. Equals, what's my first radian where I get a negative square root of 3 over 2? What did you say? Yeah, hell yeah, 4 pi over 3. 4 pi over 3 plus 2 pi n. Should we just focus on this one and then do the other one? Okay, because I don't know if you guys like going back and forth or just, okay, let's focus on just on this one. All right, I'm trying to get x1 by itself. I have pi over 6. Yes, you can say divide by pi over 6, but I like it better if you say multiply by the reciprocal. Whatever you do to one side, you do to the other. So here we go. I'm going to write x1 equals, when I multiply, let's see, those pi's go away. And I like to do it like this. 3 goes into 6 twice, and 2 times 4 is 8. That's how I like it. But I've noticed that you Generation Zers, wait, are you guys Zers or the next one, Alpha? You guys are Zers? I noticed that Generation Zers like to go 6 times 4, 28, divided, 6 times 4, what's that, 24, divided by 3, that's 8. So that's fine if you want to go that route. I don't know. What route do you guys see? What route do you see, Rodriguez? I don't see a. Oh, okay. I don't see a route. Sorry. I just know it's 8. I type it into my calculator. That's fine. Pi's cancel out, guys. There's a pi on the top. There's a pi on the bottom. Plus, all right. Sorry, guys. I got you guys all rowdy. Pi's cancel out. What's 6 times 2? 12. Put the n there. All right. That's my general expression. Let's go to the next one. Let's find the other one. I'm here, remember, at this one. So I'm going to write pi over 6x2 equals, and what other radian besides 4 pi over 3, I don't know why I said it like that, sorry, do I have sine equal to negative square root of 3 over 2? 5 pi over 3 plus 2 pi n. Did I already tell you guys that we're done with the unit circle quizzes? Okay. If you want to improve your grade, come by after school or in the morning. Okay. Are we okay so far? All right. I want to get rid of that pi over 6, so I'm going to multiply by the reciprocal. Whatever you do to one side, you do to the other. So here's another shot. Here's how I do it. You don't have to have my habits. You don't have to do it the way I do it if you don't like it. x2 equals, I see it like this. So let me slow down. I see a 3 on the bottom. I see a 6 on the top. And in my head, I go, I'm not the fastest, but I'm going to go, I say 3 goes into 6 twice, and 2 times 5 is 10. You guys see what I did? That's how I do it. You don't have to do it that way. 10. The pi's cancel out. I have a pi on the top. I have a pi on the bottom. Are we okay? If you want to go 5 times 6 divided by 3, then that's fine. 5 times 6 is 30 divided by 3. You're going to get the same answer. You're going to get 10. And the pi's cancel out. What's 6 times 2? 12. All right. We're done. Let me pick a neutral color to get my answers. I'm only looking between what and what? Okay, so 8's not an answer. 10's not an answer. But I don't have to necessarily add. I can also what? Subtract. What's 8 minus 12? Is negative 4 between negative 6 and 6? Yes, that's an answer. Comma. All right, next, I'm going to go to the 10. Obviously, 10's not in there, but I can subtract. What's 10 minus 12? That's an answer because it's between negative 6 and 6. Does that make sense, guys? Okay, let's go to number 1 that we didn't do. All right, tell me, Baye, what's my first move? Hell yeah, we add 1. What's my next move? I divide by 2. What do I do next? What do I do next, Chavez Lua? Hell yeah, we do arc sine. Okay, I'm sorry, guys. Too high. Too high. I draw a little unit circle because I recognize that's a perfect coordinate. Where is sine equal to a half? In quadrant 1 and in quadrant 2. That coordinate there is square root of 3 over 2 comma half. We're talking about sine, right? Yeah. This coordinate is negative square root of 3 over 2 comma half. Now the unit circle never goes away. I'm going to go over here. I'm going to go 3 over 2x1 equals. At what radian do I first have a half? Pi over, yes, pi over 6 plus 2 pi n. You guys told me that you just want me to focus on this one and this one only until I finish this one. So I'm just going to focus on this one. How do I get rid of the 3 over 2 in the front? Hell yeah, we multiply by 2 over 3. Whatever you do to one side, you do to the other. So I have x1 equals, let's see, 2 goes into 6 3 times, and 3 times 3 is 9. So I write pi over 9. If you don't like that, that's fine. 2 pi over 18, and that reduces to pi over 9. Not a big deal, Generation Z. Not a big deal, soldiers. Okay, I'll stop. Now what? I'm done. That 4 pi n over 3, or that 4 pi over 3 is actually the period of this function. Cool or not cool? All right, now let's go to the next one, the x2. So I'm going to start right here. So 3 over 2x2 equals, what's the other radian where sine is a half? Oh yeah, 5 pi over 6. I'm going to get rid of that 3 over 2 by multiplying by the reciprocal. Whatever I do to one side, I do to the other. And here we go. x2 equals, 2 goes into 6 3 times. 3 times 3 is 9. So I have 5 pi over 9 plus 4 pi n over 3. I'm going to get my answers now. You don't have to be super good at number fluency. You just got to have kind of an idea of what's going on. You see this 4/3 pi? That's a little bit bigger than a whole pi, because the whole pi would have been 3 pi over 3. Does that make sense? All right. My first answer, where's my first formula? 1/9 pi. Is that between 0 and 4/3 pi? Hell yeah, it is. So that's an answer, pi over 9. I go to my x2, my second equation, and I look, is 5/9 pi between 0 and 4/3 pi? Yes, this is 5/9, and you're not even close to a whole pi yet. Did that make sense? So that's another answer, 5 pi over 9. And let's see, do I have another one? Nope, that's it, because look, the period of this function is 4/3 pi, and if I add 4/3 pi, I'm going to be outside the domain because 1/9 is already positive. Does that make sense, guys? So there it is. How do we feel? Okay. Last one. I know, we're almost done. We're almost done. Let's see, what would I do? Yeah, I guess I would get rid of the square root of 3 first. So I'm going to have cotangent. And I'm going to write this, instead of writing 1/3 x, I'm going to write it as x over 3 equals 3 over square root of 3. You got that right? I don't see any issues. Should I move that into... I'm trying to think if I should. Do you guys want to rationalize that? Or no? No? Okay. I kind of want to. Okay, let's do it. So let's multiply. You guys just reminded me of, you remember that video with LeBluff? Like, just do it! No? Do you guys know who that is? Maybe you guys don't know who that is. I think his name's Shia LaBeouf from Transformers. Oh my God, guys. He was a meme 10 years ago, but you guys were little kids, right? Like 3 years old. So you probably don't know.
Like 6.
Do you guys know what a CD is?
Yeah.
No. Do you guys know what a VHS tape is? Oh, I don't know. Yeah. What does it mean when kids... I'm not YouTubing that, so I don't know why the algorithm thinks that I need to know that. All right. What am I doing? Just do it. Shia LaBeouf. I can't believe you guys don't know.
Do it! Just do it!
Okay, that's... Well, that's it. All right.
Don't let your dreams be dreams.
He's so
Yesterday,
funny.
you said tomorrow. So just do it! Make your dreams come true! Just
Thank you.
do it!
Thank you, LaBeouf. Okay. So now we're doing this. You guys didn't know about that one? Well, I don't know. I don't know how to read, miss. I can't read in English or Spanish. I tell that all the time to my people because I can't speak Spanish, but I can't speak English either. So, you know? So, I mean, I'm not really sure what I'm talking. I don't really know what I'm saying right now because I can't speak either language. Okay, anyways, so I have this, that cotangent equals square root of 3. I'm going to go ahead and turn cotangent into tangent. And I do that by just taking the reciprocal. Leave the argument alone. You can't touch that. Don't touch that. There's a song, but it's really old. It's like from the 80s, I think. So I'm going to write tan of x over 3 equals 1 over square root of 3. And, well, okay, this one I'll leave. Chop, but why didn't you leave the other one? Like, okay, well, because it's easier to see. The only way you can get that is if you have a half in the numerator and a square root of 3 over 2 in the denominator. And that happens all the time on the unit circle. On the unit circle, see? Remember, this is tan. So this is a y divided by x. So on the unit circle, that happens, and I know if you have what is it called? It's not ADHD, but like the center's off and the circle's off, and so sorry if OCD. Yeah. See, I don't know all these things. So there it is. Oh, you guys are talking smack. Smack talkers, man. Okay. So check it out. I know that I can get tan to be 1 over square root of 3 if I'm here.
How did you turn it to 10?
Oh, I just took the reciprocal of square root of 3. So 1 over square root of 3. Yeah.
Is there like a cotangent button on a calculator?
No, that's why I wanted to do tan. You know what I mean? If you have a CAS, you might have a cotangent. Like if you have an Inspire, I think someone has an Inspire over here. If you have an Inspire, you can. But this is why we want to leave it in terms of tan. You know what I mean?
Oh, so anytime we have codes. Oh, wait, never mind.
Yeah.
Sorry, I got it.
All right, guys, here we go. We're almost done. Focus. So it's true here and it's true here. Negative divided by negative is a positive. Are we okay with that, guys? All right, so there it is. So what radian is this? Well, I guess I need to first get tan by itself, right? Inverse tan, inverse tan. X over 3 equals inverse tan. That's a negative 1 there. Of 1 over square root of 3. Plus, and remember, tan has the pi n. Tan has a pi n because that's the period of tan. I know we haven't talked much about the graphing of tan, but we will. We'll do that. I'll stop because I was trying to be Shayla Bluff, but I just, yeah, that was cringe. I'll stop. Okay. You guys ready? So the first radian, so I'm going to write x1 over 3 equals, this one happens, what radian did you guys tell me that was? Pi over what? Yeah, pi over 6 plus pi n. Yeah, don't worry. And we're just going to focus on this one for now. And I want to get rid of that 3 in the bottom. So this is x1 divided by 3. So I can get rid of that 3 by multiplying by 3. So times 3 times 3. So here's my answer. I get x1 equals 3 goes into 6 twice. So this is going to be pi over 2 plus 3 pi n. What's my period? Oh, 6 pi. Good. So that means I am going to do one of those. I'm going to change my color. And I'm going to start right here at this line. So I'm going to go x2 over 3 equals, what's the other radian that I equal 1 over square root of 3 for tan? It has a 6 in the bottom as well. 7 pi. So right, 7 pi over 6 plus pi n. Are we still okay? Okay, I'm going to do the same moves that I just did a little while ago, guys. I'm going to go times 3. Whatever you have on the other side, I'm going to go times 3. And here we go. We're going to have x2 equals, 3 goes into 6 twice, so this is 7 pi over 2 plus 3 pi n. Are we okay so far? All right, we're done. Let's get our answers, and our answers have to be between 6 pi and negative 6 pi and 6 pi. So I'm going to push black, and I'm going to go x equals. So one of my answers, I guess, well, we already have positive, so we'll start here, and then in a little bit we'll get the negative ones. So one of my answers is pi over 2, comma. Another answer is 7 pi over 2, comma. All right, another answer is take the pi over 2 and add 3 pi to it. So relax, it's really easy. Just multiply the 3 pi by 2 over 2, so that's going to turn into 6 pi over 2. See, 6 divided by 2 is 3. Do you guys see that? I just multiplied the top and the bottom by 2 over 2. So see, 3 times 2 is 6, and then 2 in the bottom, and now I can add them. What's 6 pi plus 1? So, oh, MG, look at that. I got the same thing, so I don't even need to do that. I just remembered why. Dang, I can't believe I didn't remember. You know why we didn't have to do it twice? Because, I don't know if you guys remember. Yeah, remember, you just have to do it one time, and then every time you add pi, you're going to get the other answer anyways? Yeah, see, there's our lesson learned. So you don't have to do that. You can just keep adding. So you don't disregard. You don't have to even look at the second equation. You can just look at this one here. So 7 pi over 2, we already got that answer. Keep adding to it. So let's take the 7 pi over 2 and add another 6 pi over 2. 7 plus 6, 13 pi over 2. Hold on, let's see. Okay, is 13 pi over 2 an answer? No, because 13 pi over 2 is larger than 6 pi. But instead of adding, I can subtract. So start at the pi over 2. So pi over 2 minus 6, what's that? What's 1 minus 6? Negative 5 pi over 2. And then add another 6, negative 6 to that. What's negative 5 minus 6 again? Negative 11 pi over 2. Is that smaller than is that bigger than negative 6 pi? No, that is. Right? Because negative 12 pi over 6 is 6 pi. Negative 6 pi. So negative 11 pi over 2 is a little bit. I meant to put a 2 down there, so no wonder you guys are like, what? Negative 12 pi over 2, that's negative 6 pi. So negative 11 pi over 2 is a little bit bigger than negative 12 pi over 2. Does that make sense, guys? So there it is. These are my answers. And if you're scared, if you're like, Chav, I don't know if those are my real answers, you could always start right here. Let's see, where? You can always, I guess I would have plugged it. You can always plot this right here in the calculator. And watch. Let's just do it real quick for one of them. So tan x over 3, 1 over square root of 3. So look. Y equals tan, and what was it? X over 3? I'm just going to do it for one, guys. X over 3. Don't worry, we'll be done real quick. And what was the other one? 1 divided by square root of 3? 1 divided by square root of 3. And then look, we only care about between negative 6 pi and 6 pi. So negative 6 pi and 6 pi. And x scale by 1, that's fine. Y min, 8 to 10 to 10. What was my y2? Oh, 1 over square root of 3. Was it positive or negative? Positive. That's fine. I bet you this one right there, that first one, 1, 2, 3, 4. Yep, we got 4 of them. That one right there is that negative 11 power 2. The second, calculate number 5, intersect, enter, enter. And then when it says guess, I'm going to go all the way over here. Check it out. Enter. Bam. You see that negative 17.27876? So I'm going to go to my home screen. Second quit. I'm going to push X. Let me clear everything. X. I didn't clear everything at all. X. X. There it is. And then what value did I get in terms of pi? It was negative 11 power 2. Check it out. Negative 11 pi. I'm not fake, guys. It better be the same thing, digit per digit. Look at that. That's cool, right? So, or you don't like it? Volper, you don't like it? Oh, we're good? Okay. What do you think? What do you think, Granados? What do you think, Lopez? Okay. We're all right, guys? Myers, you all right? Are we okay with today's lesson? Okay. We're done. Let me give you the overview. We're not going to go over it in class. That's for you. I guess if you want to stick around after school, we can help you with it. But let me stop. Was today's lesson a good lesson for